Good evening, dear students. Today we are going to start the chapter Gravitation. Here we will quickly wrap whatever we have learned earlier. Then we will go for the next topic. Here we will discuss what is gravitation, what is Newton's law of gravitation. In this Newton's law of gravitation, we are coming across a new physical quantity denoted by capital G and called as gravitational constant. So these are the three things. Then we will learn about the new thing called free fall. What is free fall? This free fall is nothing but it is related to a term called gravity. So better term we will understand the difference between gravity. So what is gravity? So gravity is slightly different term than gravitation. It is a specific case of gravitation versus gravitation we will understand. Then we will continue with this called free fall and the term called acceleration due to gravity. This acceleration due to gravity is denoted by a small g. So if there is a small g, then it means it is representing acceleration due to gravity. So acceleration produced because of the earth pull is called acceleration due to gravity. So these are the topic, and based on this, when this is the acceleration, then how the kinematic equations get modified, like s equals to ut plus half at square in place of a, this can be replaced by new term called g. So the three kinetic equation get modified as v is equals to u plus gt. In place of a, it will be g. S is equals to ut plus half. In place of a, we will write gt square. The third one we will write as the v square is equals to u square plus 2gh. Here we will denote it by h. Okay, so it is like this. So these are the things. So this much we will cover today. These are very easy, provided once we understand. So let us quickly recap what is this gravitation. A student, we have learned this gravitation is nothing but it is a force of attraction between any two masses. If there is any two mass, they will attract each other. Whether you consider yourself and the wall is attracting you and you are also attracting the wall. But the wall is not able to move because wall is fixed. You are also not able to move toward the wall because this force of attraction between you and wall is very, very small. But if you are jumping upward, then you are returning back. Why? Because the earth is attracting you and that force is very large. Okay, because of large mass of earth, means more the mass, more this gravitational force. Okay, so this gravitation is nothing but the force of attraction between two masses. If we consider, see this figure, m1 and m2 as the two mass, then these two masses attract each other by the same force denoted by F, and this F is depending on the mass of these two objects and the separation between the two objects. It doesn't depend on the medium between the two objects. So this force of attraction is given by the formula F is equals to G m1 m2 by r square. m1 m2 denote the mass of each object, r is the separation. So this formula is called as Newton's laws of gravitation. We will discuss in more detail. So student, the same is denoted here. In this case, m1, m2 are the mass of two objects, but the term capital G is a new quantity called acceleration due to gravity. So this is a new quantity given by Newton, because this formula was given by Newton. So that's why this is also called as Newton's laws of gravitation or Newton's formula of gravitation. So how is this gravitation? Gravitation is simply force of attraction between any two mass. Means if the mass is more, the force of gravitation will be more. So this force depends on the two masses, and this force is always attractive because mass are neutral body, they do not repel. But charges like the like charges, poles means like pole, like both north or both south, they repel each other. But between two masses, there cannot be any force of repulsion. So between two masses, there is always a force of attraction. That attraction force is called as gravitation. If we consider just two mass, m1 and m2, then there is only one pair of force, because m1 will attract m2 toward it, the m1 denoted by f21. So here we are observing that this m2, so over this m2, the force is applied because of presence of m1. So that force is denoted by F21, means force on mass 2 because of mass 1. Similarly, this m2 will also attract m1 toward m2. That force is denoted by this F12. The naming is like this: force on 1, this one corresponds to this suffix 1 because of the mass 2. This gravitation is what? Force of attraction between any two mass. Because of m2, the force F12 is applied over the m1. So it was between the two. If there is three masses, in that case we have three pair of forces, or total 6 forces. Say m1, this m1 will try to attract m2 as well as m3 toward itself, denoted by blue line or blue arrow toward m1. Also, the m2 will attract m1 as well as m3 toward m2, denoted by yellow arrow. Also, m3 attract m1 and m2 toward itself, denoted by black arrow. Okay, so this way there are always 6 pair of forces. A student, the force between m1 and m2, they are always equal, whether the force is acting on m2 because of m1 or on m1 because of m2. These two forces will be equal. Similarly, between the force or between the mass m2 and m3, the forces means yellow arrow and this black arrow, these two forces representing, they will also be equal. But these two forces may be different from the force between m1 and m2. This I may denote this by f dash, then this will also be your f dash. If I denote the next pair by f double dash, this will also be your f double dash. Okay, so between two objects, the force of attraction are always equal. That's why the force with which Earth is attracting you, with the same force you are also attracting the Earth. But because of large mass of Earth, the movement of Earth will be very small or negligible. So you cannot feel that Earth is moving toward you. But because of large mass of Earth, the force exerted on you, that will be very, very large, and you will come back on the Earth's surface. So it is because of this mass. So what is the law governing this F? So that law is called as Newton's laws of gravitation. Gravitation is what? Force of attraction. So between any two mass, the force is directly proportional to product of their masses and inversely proportional to a square of their distances. And this force is always acting along the line joining two masses. So M1 and M2 are here two masses. So on mass M1, the force F is acting because of the M2. Also on mass M2, the same force F will act toward M1, and this force is because of the presence of M1. The distance between the center of two masses is taken as R. If the size of this object is very small, then the R may be considered from the surface of one object to another object. Okay. For better understanding, it is the center of mass is taken, means the center point of mass is taken. Student, so therefore the law is given by F is proportional to M1 into M2. Means if more mass or more the product of masses, the force will be more. But the same force is inversely proportional to a square of their distances. Means if the distance is increased, the force will decrease very fastly. Combining these two, we can reach to the formula F is proportional to M1 M2 by R square. For removing the proportionality by equal sign, we need some constant, and that constant is denoted by G here. It is called the proportionality constant, and it is determined experimentally. It was determined by Newton, and the value is given as 6.67 into 10 to the power minus 11 Newton meter square per kg square. So this is the unit. So unit is also important. This value is in SI unit. If you consider in CGS, it will come at 10 to the power minus 8. And this value of G is always constant. It doesn't depend on whether you are observing the force of attraction between two masses on Earth or moon, or between moon and sun. So anywhere throughout the universe it is constant. So therefore it is also called as universal constant. The unit for this F is what? F is denoting the force. This is the force of gravitation or gravitational force. So force can be various type. If it is between the two charges, it is called electrical force. If the charge is at rest, it is called as electrostatic force. Force between two magnet or magnetic pole, called magnetic force. Okay. Between two masses, called gravitational force. Inside the nucleus, called nuclear force. So various type of forces are there. So this gravitation is nothing mean, simply gravitational force given by Newton's laws of gravitation. M1, M2, the unit will be in kg, and R is the distance which will be measured in meter. By knowing the unit of these force, masses, and separation or distance R, the unit of G can be calculated. So the unit of G is calculated like this. So substitute the known unit, means the force, distance, masses, you can calculate the G. For calculating G, you may first rearrange this formula itself. So rearranging, we are able to get G is equals to F R square M1 M2. Okay. So therefore this G, the unit of G will be equal to unit of force multiplied by unit of R square divided by unit of mass M, unit of mass M2. It becomes Newton meter square per kg square. It is like this one. So this was the unit of G. Along with the value, this is what SI unit we have taken. It is 6.67 into 10 to the power minus 11 Newton meter square per kg. This value is very important. You have to keep in mind. It is useful everywhere. Whether it is given in question or not, it is always available with you. One numerical was taken. So two masses. One is 50,000 kg and other is 2 into 10 to the power 7 kg are separated by 100 meter. What is the force of attraction? Means this force of attraction is what? Gravitation. So what is gravitational force? So this is the gravitational force that we have to calculate. So whether gravitational force or what is the gravitation mean the same thing. So for this gravitational force, the formula is F is equals to G m1 m2 by r square. Just substitute these values and solve it carefully. A student, where is there is exponent or 10 to the power something, you should be very much careful while solving this. Okay. So take the numerical value at one places, then apply the mathematics of for the exponent like a to the power m divided by a to the power n, that formula, or a to the power m into a to the power n, that formula. So by applying that, we are able to get the value is 66.7 10 to the power minus 4 or 0.0067 Newton. So this was the answer. How is that? So everything is also explained in previous videos. So you can watch those videos once more. Then another important question. So two masses m1 and m2, they are placed somewhere. That is the value of mass m1 and m2 is not known, but the force between them is known as F. Now these masses are brought closer to each other so that the distance is now reduced to half of its original distance. So this was the case 1 or situation 1, but in new situation or situation 2, the separation is reduced by r by 2. And we are knowing that either the mass is changed or the separation or gap between the two masses is changed, then the force get altered. So what is the new force that we want to calculate in this question? So for that, what is given, the first situation you draw it and write it in the form of formula. So let the two masses m1 m2, separation r, then there must be some force of attraction F, which is also given in the question. So this F can be written in the term of m1 m2 and r, whatever we have assumed in this case. So F is given by G m1 m2 by r. Now what is the new situation? You also draw it. Now see, the distance is reduced to half, means the new distance r new is r by 2. Therefore when the distance is changed, the force F will also change. So that force is denoted here by F new. So what is this value of F new? This we want to calculate. This is the question. So for F new we need G. Now the masses remains unchanged. So we have to keep the mass unchanged, means M new or M1 new is same as M1. M2 new is also same as M2. So mass are kept unaltered. Therefore the F new will be G M1 M2 by R new square. So R new is simply R by 2 square. So we have to simplify this. It becomes R square by 4. Then go for the cross multiplication or conversion of division of ratio into their multiplication. This 4 will come in numerator. Now observe, this becomes 4G M1 M2 by R square. This G M1 M2 by R square is what? The initial force, whatever the F given. So that we have substituted here. Ultimately we are getting the new force is 4 times the initial one. So force is increased by 4 times. This is the simple kind of question which is framed. It may be given that the masses are also changing while the distance kept unchanged, or both masses as well as the distance is changing. So that kind of question is also asked. So just what is the condition, you have to apply it properly. Student, this is the question taken from your textbook, exercise question number 6 we have taken. In this case, you have to determine the new force under different conditions. The different conditions are, once the masses or one of the mass is doubled. In the next case, distance between the two objects is doubled and tripled. Then one of the mass is doubled and distance between them is also doubled. So these are the situation, three situations. So student, in this case or in such situation, you have to just consider the initial situation and you also have to write the new situation as per the condition given. Then you have to determine the new force. So what happened? This is the question. Happened to the force means what will be the new force? F new we want to know. So this will always be in the term of the original force, whether the new force is doubled or tripled or half or multiplied 4 times or divided 10 times. So what is the factor that basically we want to know between two objects if this is the situation. So student, take the first situation, write it. So for doing the first situation, let us first understand what happened to the force. So you just consider two mass, consider them, one as m1, another as m2. The distance between them means between their center, you may denote it by the r itself. At this time the force is our F or F original or Fi we may consider. Okay, so this is the force we are taking. This is the general representation. In this case, you have to write the formula for force. So this F is given by m1 m2 by r square multiplied by g, that is also the universal constant, g we have to take. So this is the formula for force. This is the general case wherever gravitation is there. Now you have to draw one by one. What are these situations? So in first case or in first situation, mass of one of the object is double. So you are free to double either m1 or m2, not the both, because it is given as one object is double. So let m1 or m1 new is double, twice of m1, but m2 is here unchanged because nothing is given for this, as well as this separation r is also unchanged. So those quantities which are unchanged, you do not worry for them. Means how is this situation, new situation? If you want to plot it, now the new mass is double of the initial or original mass. This is our m1 new, which is nothing but twice of m1. We may think like that. The gap remains the same, means this is also r, and this mass is kept unchanged, means m2 itself. Okay, now what will be the force? F new, this will be our, what is going to change? You have to change those quantity. So m1 is changed to m1 new, so new mass you have to substitute, but m2 remains unchanged, so keep this m2 as it is. The distance also remains unchanged, so keep this r as it is. This is m1 new is nothing but twice of m1 m2 by r square. Here we are getting the factor 2 is here. Because of this 2, this can be written as twice of m1 m2 by r square. Right, the g is always there, so we may keep the g here. So g m1 m2 by r square So these are the situations. Here we can substitute this gm1 m2 by r square using this 1. 1 is our, this is denoting the twice of F. Means this new force is doubled. So therefore conclusion you have to write, force get doubled. This is the comment you have to write. Force get doubled. Or new force is twice of the original force. So what happened to force? So the force get doubled. This is the answer for first case. If I consider the second situation, student, distance between the objects is doubled and tripled. Here itself two conditions are given in this second. One is doubled, another is tripled. So here you have to write for distance doubled, r new is equals to twice of r original initial r. So this is the one situation we have to write. Another time it is also asked for r new is thrice of r original, because doubled and tripled is not possible for the same position. So we have to draw it separately. So mass remains m1 and m2. It is not talking about mass. So whatever initially we are taking the same mass we have to take. So keep this mass m1. But the new distance is our, this is m2. But the new distance is our doubled, means 2r, means the r new is our twice of r. This is required. Therefore, what will be the F new force? It will be given by G m1 m2 by r new this much square. Student, we can neglect the drawing figure again and again. Just by substituting r new is equals to 2r, we can get it. So G m1 m2 by, in place of r new, we have to put twice of r original, which was denoted by r itself, and its square. So this 2 square become 4. G m1 m2 by 2 to the 4 r square. Now student, these terms, this is acting like our F original. So this can be written as F original by force, by 4. Means force become 1/4. So the force becomes 1/4. So this is the comment you have to write. But when it is tripled, in this case, again we have to apply the same thing, the same kind of figure. F new for tripling will be given by G m1 m2 by r new. But in this case, r new is our 3r, it's a square. So it will become G m1 m2 by 9r square. So this 9 can be taken out. Numerator, this is the capital G, and denominator it is 9. So 1 by 9 can be taken out. This thing can be written together. G m1 m2 by r square. This is denoting your F original by 9. So force reduced by, or force become 1/9, become 1/9 of original. So this is this situation. Now this was the second condition. Now coming for the third one, mass of both objects are double. Student, in this case it is talking about the mass of both the objects. So this third situation is like this. M1 is replaced by the new M1. So this is nothing but twice the mass of the first one. Also, the mass of second object is also changed. So M2 new is now, this is also twice of M2, because it is given that both object is double, talking for the mass. But in this case it is not talking for the distance. So R, it is unchanged. If you want to draw the figure, you can draw like this. So in this case, this is our M1 new. This is twice of M1. This is our M2 new. This is twice of M2. This separation remains the R, whatever the initial figure was, that means I am talking, this was the initial figure that we had taken. So with reference to this figure, always we have to consider or draw the figure. So here we can also write like this. So what is the force nu? F nu that we want to get in this case. So F nu is given by G M1, the new mass in place of M1, M2, the new mass, divided by the separation R. R is unchanged, so we may keep it as it is. So G twice of M1 multiplied by twice of M2 divided by R square. Student, these two can be taken out, means 2, this first 2, second 2, number can be taken together, and the other thing can be written, the G M1 M2 divided by R square. We may write this as the 4, 2 to the 4, then G M1 M2 by R square. Now this G M1 M2 by R square can be written as F, applying the condition or initial condition that we have written at the top. Okay, students, see here. Okay. So therefore, substituting that, we have written this. So what this indicates? So the comment is like that. The force become 4 times. This is the comment that you have to write. Force becomes 4 times. So here we can understand, when both the mass is doubled or even the distance is just reduced to half, every time the force become 4 times. Student, here in the first case only one mass was doubled, so it was just doubled, but in the third case both mass were doubled, so it become 4 times. This thing we have to keep in mind. So this way, applying the conditions, we can calculate what is the effect over the force when the mass is changing, when the distance is changing. So this was all about the laws of gravitation. Now what are the importance of this gravitation? A student, while we are jumping upward, we are able to fall back on the earth. It is because of this gravitation, because earth pulls us toward itself. So what are the importance? The very first importance is earth binds everything toward its surface. So like even the atmosphere that exists around the earth, it is because of the earth pull. The earth is pulling the gaseous particle toward itself. That's why atmosphere can exist over the surface of Earth. But this atmosphere cannot exist over the moon or other smaller planet. Why? Because of their smaller force of gravitation. So, right? So, this gravitation or Earth gravitation or gravitational force binds us or everything toward its surface. It is this. The second one, many a time, in MCQs, the question is asked, why the air or atmosphere exists around the Earth? Or the atmosphere exists around the Earth because of Earth pull or just existence of large gaseous molecule? Okay? Or the gas cannot escape out? Various options are given. So that you also have to understand, it is because of the Earth attraction force over these gaseous molecules. They are present or they are spread all around this Earth called atmosphere. So, right, existence of gaseous envelope around Earth. This gaseous envelope around the Earth is called atmosphere. So this atmosphere exists because of this force of gravitation of the Earth. Another, we are observing or we have listened that moon is rotating around the Earth. Why? Because of this Earth gravitation force over the moon is able to rotate around the Earth. So, right, moon rotates, it is basically revolves, not the rotates. Rotation is on the axis, revolving in an orbit. Moon revolves around Earth. Okay, that we have learned in our earlier standard also. This is the Earth. If I consider this is the Earth, then moon is rotating over this. So this is the moon. Okay. In the similar fashion, this existence of solar system. So moon rotate around the Earth or the satellite. The same, because of this Earth attraction, even the artificial satellites are able to rotate around the Earth or satellites around a planet. This moon is our natural satellite. Okay, but if we are putting artificially some of the satellite for communication purpose or other useful purposes, that is called the artificial satellite. They are also based on the same thing, but this artificial satellite have very lesser mass, but this natural satellite like moon or other planet also have this natural satellite, so they have very large mass. Even the planets revolve around the sun. So planets revolves around sun. That is solar system. So this solar system exists because of the force of attraction or the binding force by sun. This is the sun, and all the other planets revolve around this in different orbits. Okay, so it is like this. The earth will also rotate. So Mercury, Venus, it will be the earth, it will be the Mars, like that one. So they will also rotate around this sun. So this way forming the solar system. Even the earth rotate around the sun, but around the earth the moon rotate. So moon will continue to rotate around this earth, as well as it will also move around this sun. Okay, though the center of movement for the moon will be the earth itself. So these are the importance of gravitation. So gravitation is very important for the existence of solar system or existence of even galaxies also, like our Milky Way galaxy, which is existing because of this force of gravitation. So it is because of the gravitation this universe exists. So it is this one. Now student, we have to go for the new topic called free fall. Before understanding this free fall, we shall understand a term called gravity. Like gravitation, there is a specific term called gravity. A student, this gravity is nothing but it is a special case of gravitation. Gravitation is the force of attraction between any two mass. Say force between you and your brother sitting around you, that is the gravitation. But the earth is always attracting you toward its surface. The earth is also attracting your brother toward the surface of earth. The earth is also attracting this building. Earth is also attracting the mango hanging over the tree. So this special kind of force of attraction of an object toward the earth is called gravity. Okay, so it is also the gravitational force, but this force is between the object and the earth. Okay, so right, it is a particular or a special case of gravitation where one mass is always, what is that mass? It is the earth. Okay, so gravitation is between any two mass. So if I talk for this gravity and then this gravitation, so this gravitation is between any two mass. Whatever the mass m1 and m2 you are considering, between any two mass. But this gravity is always between the earth. So earth is one of the mass and any other object m. Okay, so it is this force. So earth is attracting this object toward itself. At the same time, this object m will also attract the earth. So right, this gravitation, it is between any two masses. Any two mass. Gravitation means the force of attraction. This gravity is also the force of attraction. So it is between Earth and any other object. So one of the object must be Earth in this case. It simply means that. Now the laws applicable are exactly the same. So that's why this gravity can be called as Earth pull. So right, it is, or definition is like this. If anyone is asking to you about the definition of this gravity, so gravity is the force of attraction. It is force of attraction between an object and the Earth. An object and Earth. It is this. So it is always between an object and the other object is always Earth. But it is force of attraction between any two objects. It need not be the Earth. Okay? And this force is always attractive. So this is also called as Earth pull. Earth pull means Earth is pulling everything toward its surface. The force with which the Earth is pulling object toward its surface is called gravity. So force with which Earth pulls an object toward itself. This is called as gravity. A student, now here in case of gravity, one thing is fixed. One of the mass will always be the m or mass of Earth. So one mass is fixed. Mass is always mass of Earth. M Earth I am denoting. Okay, or simply m. If this is the Earth, consider this as the surface. There is another object. So this is any other object. Then Earth will pull this object toward its surface. At the same time, the object will also pull this Earth. Now, if we denote the mass of Earth by capital M and mass of this object by a small m, then this force F can be quantified or given. Consider the separation or the gap between the Earth center and the mass m by a small r. This is this gap. Then what is gravity? Gravity is same as this force between Earth and force between Earth and object. Now this force is because of the mass. So this is same as F denoted by, for giving the gravity, we are using the small g in the bottom of this F to denote it. This is the force of gravity. Now this force is given by the same formula as Newton's laws of gravitation, which is G means capital G here the mass, one of the mass is mass of Earth, the other mass is mass of the object small m, and the separation between them is r. So force of gravity is always fixed and it is given by G, mass of Earth, mass of the object, by the separation r. This term we have to keep in mind. But this gravitation was between any two mass that we were denoting. As we have learned earlier, this separation we may denote by r. So it was G m1 m2 by r square. Okay, so this was the general case which is applicable for everything. Okay, whether sun and earth, whether earth and apple, whether moon and earth, whether sun and moon, all these things. Okay, so because of this gravitation, the various phenomena like existence of atmosphere, even the tide is also there. You may write it here. Another phenomena here, the another important phenomena called the tide you are observing in the ocean, tides in ocean or sea. So these things are also because of this force of gravitation over the water present in ocean and the moon, as well as force of attraction between the water present over the earth's surface and sun. But moon is more closer to the earth, therefore the effect of moon is more pronounced. Okay, so it is that one. So existence of tide is also a special case of that. Now this coming to back to this gravity. Gravity is simply the force of attraction between the mass and any other object. It is this one. A student, now if we consider if a force is existing, then it will give rise to acceleration. Why? Because if any object M is there over which the force is applied, then we have learned that this force is given by mass into acceleration. So therefore the acceleration is obtained by dividing this force by mass. Are we getting like this? Since why? This force is given by mass into acceleration, therefore even the force is given and mass is given, then its acceleration can be calculated. So by that way we are observing that acceleration is produced. So write that statement: when a force is acting on a body, when a force is acting on a body, then acceleration is produced. Then so acceleration will be produced in that body. Okay, will be produced and given by ratio of force and mass. Now here we have to understand this force is called the gravitational force, This gravitational force is given a specific name called gravity. It is because of the earth. So force of gravity. So gravity or force of gravity mean the same thing. Now when this force is acting over the mass, this mass is what? The object over which the force is exerting the, so force is exerted by the earth. So their ratio means this gravitational force Fg and the mass of the object m, this will give rise to acceleration. So in this case, the acceleration produced is called as acceleration due to gravity. Okay, so it is called as acceleration due to gravity. So why it is called as acceleration due to gravity? Since by Newton's second law, we have learned that when a force F is applied over the mass m, the acceleration produced is given by F by m. Okay, it is this one. But in this case, this F is a special kind of force called gravity force, and mass is the mass of the object. So this is F gravity. Therefore, this acceleration is also given a name called acceleration produced because of the gravity and called as acceleration due to gravity. Okay, student? And this acceleration due to gravity is denoted by the alphabet small g. So these things we have to keep in mind. So this acceleration due to gravity is nothing but it is our acceleration produced because of the force of earth or because of the earth pull. So right, therefore, what is this situation? This situation is like this. This is the earth whose mass you may denote by capital M. There is any other object which is at certain height, you may denote it by a small m. Then this object will be attracted by a force called Fg. Okay, here Fg or acceleration due to gravity that we are denoting. Because of this Fg and m, we are able to get the acceleration A. This acceleration A is denoted by a small g, and this acceleration A is nothing but ratio of the force by mass. In the similar fashion, this acceleration A denoted by g, F is nothing but Fg divided by the mass m. Here we have to keep in mind the mass is the mass of the object, not of the mass of the earth. So that we have to keep in mind. So this is the situation. The separation between the earth's center and the object, we may denote it by a small r. So therefore, what we can write? Acceleration due to gravity so this acceleration due to gravity is given by force of gravity divided by the mass of the object. So this is important. Student, it is the mass of the object, not the mass of the earth. This acceleration due to gravity is denoted by a small g. The force of gravitation, Fg, that we may denote, or a small g, and the mass of the object, a small m. Now this Fg is what? Recall the formula that we have written for the gravity, the force of gravity, or the gravity here we have written at the bottom. Recall this. So it is given by G, capital M, small m by R. Capital M is mass of earth, small m is mass of object. R square is the separation between the two masses. Student, so substitute it. G, capital M, small m divided by the gap between, the same figure is also denoted. Okay, it is denoted in vertical by R square divided by whole divided by m. Okay, now here we are getting that it simply means G, capital M, small m by R square is there, then a small m is there. So these two are getting cancelled. So ultimately we are getting this G m by R square. So whatever this formula that we are getting, small g is equals to capital G, capital M by R square. This is very important, and the value we will calculate next day. Here, this G, small g denotes the acceleration due to gravity. It is a kind of acceleration. So thus, we have to keep this formula in mind. Capital G, the mass of earth by R square. Okay, so this is what the acceleration at certain distance r. So if this is the mass capital M of the earth or any planet, there is another object at certain distance r, then because of the force of attraction and acceleration g toward this planet M will arise, and this acceleration is given by capital G M by R square. This is very important. More analysis we will learn. So where this G denotes, call the acceleration due to gravity, means because of the earth pull. Gravity simply means the earth pull. Capital G denotes the gravitational constant. This capital M denotes the mass of the planet of, in this case, it is the earth that we are considering, but this formula is valid for the moon also. What is the acceleration due to gravity of moon? Also applicable for the other planet like Mars or other. So at that time we have to take the mass of that planet or that satellite. The R denotes the distance at which this acceleration due to gravity is considered. So distance from center of planet to the point where we want to know this gravity, to point under consideration. This simply means, here this is the capital R. A student, Earth is taken nearly spherical in shape. It also have its own radius. So alternatively, this may denote like this. If we consider the radius of Earth as R, and if the object come closer to the Earth's surface, then at this time the small r is given like this. Okay, this much is a small r. If the object come at here on the surface, so a small r become equal to capital R. So we may denote, for better understanding, we may denote this R as like this. So let me consider the object at some larger distance. This is the small r, means the distance of the object from the center of Earth. If capital R denotes the radius of the Earth, means this is capital R is the distance between the center of Earth and the Earth's surface. Now if we consider the distance of the object, or the point where we want to know this acceleration due to gravity from the Earth's surface, by h. So this is the height above which we want to know the acceleration due to gravity. At that time, this r may be your capital R plus h. Okay, it is very important. If at surface, at Earth surface, means the h value becomes 0, so this r may be replaced by capital R. Okay, so these are the possibilities. So what are the possibilities that we will discuss later? So this is the meaning of distance under the consideration. Here, by substituting the value of g and mass of Earth, which is fixed, we can get the value of g, a small g, called acceleration due to gravity, as 9.8 meter per second square. The unit is meter per second square. Why? Because it is acceleration. So whatever the source of this acceleration or source of force, but the unit of acceleration will always remain the same. Just for convenience, we may approximate 9.8 is very closer to 10 meter per second square. So for simplicity, but this is the more accurate. It is more accurate. This we will calculate in our next class. It is approximate. So this is for convenience of calculation we are taking. So rather than solving 9.8, 10 may be taken. So it was all about. Now we shall stop the class here. Next day we will learn more about this. What is the acceleration due to gravity? How this value is calculated? How this acceleration due to gravity changes at the moon and changes with height and depth from the Earth's surface? Those things we have to learn. And based on this, if the body is moving under this, the influence of Earth pull, or under the condition of acceleration due to gravity, it is called as free fall. So we will define those conditions later. And under this free fall condition, the kinetic equation get modified by g in place of acceleration a. So all the three kinetic equations are also applicable in this case. Now, student, you have to do the homework. What could be the homework, student? Yes, quickly tell me.